Hello and welcome to day 6 of Advent of Cyber 2025. Today's challenge is all about malware analysis, and in today's video, we're going to be performing static and dynamic analysis on a malware sample. So without wasting much of our time, we're going to scroll all the way down to the task section. We have the introduction and the malware analysis using Sandbox. So let's go into the introduction. Here we have the storyline for today's challenge, as well as the learning objectives for today's challenge. In today's challenge, we want to learn about the principle of malware analysis, sandboxes, static and dynamic analysis, and lastly, tools that are being used in static and dynamic analysis, like the PE Studio, Procmon, and Regshot. In the next section here, we have connecting to the attack box, or to the remote machine rather, or you can also call it the target machine. And this is very simple. All we have to do is to click on the start machine, and this will take 1 minute to spin up our machine. When this is done, we will have our IP address populated right here. So I'm going to exit split screen view, and here we have our credential like the username, the password, the IP address, and the connection type, which is RDP in this situation. So this is an indication that we'll probably be using Windows machine on this particular task. Lastly, we have a note here which says, please note it is imperative that you do not execute the hopheler.exe executable yet. The ROM will instruct you when to do so. So this is an instruction so that you won't mix the whole process up. So what we're going to do here is to just click on check to confirm that we have successfully started the sandbox. Now we're going to scroll all the way down to task 2. We already have our IP address, and what we want to do here is to move straight to the question and answer. Now, before we start answering this static analysis question or dynamic analysis, let's move ahead to the introductory part so that we can understand what malware analysis is and what is the difference between static and dynamic analysis. Malware analysis is a process of examining a malicious file to understand its functionality, operation, and methods for defense against it. By analyzing a malicious file or application, we can see exactly how it operates and therefore know how to prevent it. For example, could the malicious file communicate with an attacker server? We can block that server. Now, when we talk about the different types of malware analysis that can be done, most times we're talking about the static and the dynamic analysis. And what the static analysis usually mean is we're trying to analyze and understand how a specific malware file operates without actually executing that malware. In the case of dynamic, we need to execute the malicious file so that we can see the kind of operations that are being made or the kind of requests that are being made by that application within the entire file system of our operating system. Now, we're also being introduced to sandboxes, which is more of like a controlled environment where we can practice malware analysis so that we will not interfere with our host operating system or infect any sensitive data within our system. Now we're going to scroll all the way down here. Remember, the malware artifact or the malware sample we're going to be using for this challenge is called hopheler.exe. So jumping right into the challenge, first thing I want to do is to go to my terminal. So let's use the down one, and I want to start my VPN. So let's go to where I have my VPN file downloaded to, and I want to do sudo if it's gd, which is my VPN file name, and I want to enter my password, and this is going to connect us to the TryHackMe VPN. You can see our IP address at the top right corner here. So let's go back to the other terminal. Now, if you go to my Notion note here, I have the command to connect remotely via RDP using a tool called Xfree RDP. So we're going to copy that command here, and we're going to go to the terminal and we're going to execute this. Now we need to supply the IP address and the username. So we need to go back to the introduction section of the lab guide so that we can grab the necessary credential to authenticate. So let's head over here. And when you scroll to the connect machine, you see that we have our username in here. So let's put that here. And in the case of our IP address, we need to supply the IP address being generated by the lab. So let's paste that in here. And then we can execute this. Remember, we are using scale of 140 so that we can probably see the full screen of the entire Windows target machine. So let's pick the password and I'm going to paste that in here. And that should launch our target machine. So it's coming up. We're already logged in. So this is going to be our working environment here. And we have some basic malware analysis tool installed already. We have the PE Studio, which is used for static analysis. We have the Regshot, a dynamic analysis tool. We also have Procmon, which we can use to perform dynamic analysis. So since we're starting with static analysis, I'm going to launch the PE Studio. And this is how the environment looks like. I'm going to expand this. And we can go to our machine. Let's minimize that for now. We can launch the hophelper folder, which contains the hopheler.exe, which is our malicious file. Now remember, from the introduction, we said when performing static analysis, we are not expected to run the malicious file. So what we need to do is to go to our static analysis tool, which is the PE Studio. We just drag and drop our malicious sample in there. So I'm going to minimize the Explorer and then maximize the PE Studio. All right, great. So this is how the environment of the PE Studio looks like when you load an artifact into the application. Now, on the left hand side here, we have our navigation through the entire system of the malicious binary file. And the very first thing we have here, while selecting the actual hophelper.exe, is our checksum. Now, this checksum is used to uniquely identify that specific payload. And this is very important where we want to keep track of a specific payload on our system. So there are some detection mechanisms which we can put in place whereby we use the actual hash to detect the presence of a specific malware within an application. In such situation, this checksum of that file can help us to quickly identify that particular malware whenever it gets to the system. Now, what we're going to do, since this is what the first question is asking us to do, is I can copy the value and head over to our tags 2 on the question and answer section here. So the first question says, on static analysis, what is the SHA-256 sum of the hophelper.exe? So we have the checksum already. I'm going to just click on check to confirm our answer. Now, you might be wondering, okay, how do I keep track of this particular hophelper.exe? You can go to platforms such as virustotal.com and then you can search or query the VirusTotal database with this specific hash type. You can see it. We can either query based on URL, IP address, domain, or file hash. Now, if this particular hash is present in the database, definitely this is going to pull that out from the database. And one very interesting thing about VirusTotal is that it also allows us to compare the different analysis from different security vendor based on the search term. Now you can see that VirusTotal has been able to dictate this checksum to be hophelper.dll. And if you scroll down here on the detection tab, you see the comparison between the different security vendor and their analysis result here. So to proceed with our lab, we're going to move to the second section here, and it says within the string of hophelper.exe, a flag with the format THM exists. What is the flag value? Now, if you go back to our environment here, we also have other options aside from just looking at the checksum of the malicious file. We have things such as strings, which can contain things like credential, passwords, API endpoint, IP addresses, any good information that can reveal sensitive information about the malicious file being executed are mostly usually found inside the string. Now, if you go to this section here, or you go back to the challenge, I think there's a section which explains that better. Now on the string section, it says strings are a sequence of readable character within an executable. This could be, for example, an IP address, URL, command, or even passwords. So we also have other section within the PE Studio, like the import, which are the list of libraries and functions that the application depends on. For example, rather than building everything from scratch, application will use operating system function and library to interact with the OS. So those are the kind of information we can find in the import section, and we also have the resource section of this PE Studio. So for now, based on our tasks, all we have to do is to visit the string section here, and we're going to scroll all the way to the bottom of the page where we're going to find the flag we're looking for and other string as well. So let's pick that up and scroll to the bottom. Now you can see that we have the THM string which appear more than once. So let's just pick any one and copy the value, and let's scroll all the way down to the question and answer, and we're going to be pasting that in here, and I'm going to click on OK. Now you can also explore other parts like the imported libraries within the application of functions. We also have a section specifically for the libraries. You can see the kernel32.dll, which was used by the malicious executable file. You also have the debug, the resources as well. So let's try to see what is on the resources. We have just the version and the manifest. So let's go back and proceed on our quest. Now, having completed the static analysis task, the next thing would be the dynamic analysis. So what we have to do is to close the PE Studio. It is no longer needed for now. Now, if you notice, when performing static analysis, we did not execute the malicious file because we needed to just decompile the file and find the relevant information within the executable binary, such as IP addresses within the strings or even the checksum of that specific file. But in the case of dynamic analysis, we have to execute the payload and try to capture the current state of that system and see what kind of modification that particular malicious file is making to our entire file system. And a better way to do that will be using the tool called Regshot. Now I'm going to be explaining how Regshot works in just a minute. So let's launch Regshot. Now the Regshot works based on snapshots, and the way it works is it first of all takes the initial recording of the entire window registry, and then we're going to execute our payload and then take another snapshot after the payload have successfully executed, then we are going to compare these two snapshots to see what has changed from the initial snapshot after the malicious file has been executed. And to do this, we're going to first of all set the output path. We're going to just pick desktop to be our output path. I'm going to click on OK. This is just the location where the result of the snapshot is going to be saved to. So we're going to take our first snapshot, click on shot, and this usually take about 45 seconds to 1.5 minutes to record the entire Windows registry. Okay, we have our first snapshot taken already. The next thing we want to do is to go into the hop helper directory or folder and then execute our payload. So I'm going to just make this a little bit smaller so that we can take a look at the behavior of the desktop environment when we execute the hopheler.exe. So I'm going to double click on that, and you notice what is going to happen to the images or the icons of these different shortcuts to these applications. And you can see them, it has changed all the icons to a different icon. And we have a notification on the screen saying King Malware sends his regards. We're just going to click on OK. So that is the entire behavior of this particular malicious file. So now we can take our second shot since we have already executed the malicious file. Now this one is just going to take about maybe 5 to 10 seconds to take the second snapshot. Then we can compare both snapshots. When it is done, you'll see that the compare button will be activated for us to compare both snapshots. Okay, so we are done with the second snapshot. Now we have to compare both, and this will automatically open the results on the desktop. So you can see the result file has been created as resx64.txt. So we can make this bigger so that we can take a look at what we have on this file. So these are the kind of things that are being modified, values that are being added, in this case 5, in this case 28. So let's just scroll down and try to see the final summary. So we have about 36 total changes being made to the Windows registry. Now we have a lot of different registry here, but what we can do is to find the specific one for the hub helper. So let's click on find next. Okay, I think we're at the bottom of the page. So what we can do is to change this to up. We have hub helper. Let's go to the top. So we have a lot of them. Let me go back a bit. System is really slow. Another thing I can do is let's just start searching from the top. Let's move this to the top. Okay, so this is the top. Let's search now. Which one is the first one? So I think this one's are the first one. From the hard disk volume, a specific user called DFIR user. Let's switch this to down and find the next one. This is still on the same line. So let's scroll to the left. Now let's try to understand what we're looking for. Now for the dynamic analysis task, we're looking for what registry value has the hophelper.exe modified for persistent. Now when we talk about persistent, we're talking about a situation where a specific malware has modified the registry entry by adding itself automatically to a specific key part. Whenever that specific user logs into that system, that application will automatically start without any user interaction. That is what persistent means in these situations. So in order to find that, what we can do is to head over to the result here. I can just copy this. So this is particular registry high for specific user. So I'm going to be going with this ones. So let's copy the one that has the hophelper.exe, which is this line. And I'm going to copy this and let's take it to maybe ChatGPT. What is this doing? And let's try to search that so that ChatGPT can explain better what this particular registry is talking about. But remember, this is the specific part to the application on this DFIR user's account. Now it says that registry entry is being used to make the program hophelper.exe run automatically every time that user logs into Windows. So this is basically what we are trying to say here when it comes to persistent. So in this case, we'll just grab the registry only. So I think that is what is being required of us, or you can choose to grab it from here, just this. Let's scroll back a bit, grab it from the beginning up until this point. We might need to add R to that. Check. That was correct. Now for the second section of the dynamic analysis, it says filter the output of Procmon, which is another tool usually called process monitor. So we're going to be filtering this tool for TCP operation. What network protocol is hophelper.exe using to communicate? Now, sometimes malicious file goes beyond just modifying the Windows registry. Sometimes they go ahead to make connection to a C2 server from a different location using a specific network protocol. Now, for this task, we are asked to investigate such situations by filtering the result of the Procmon, which is process monitor, for the TCP operation, and then investigating what kind of network connection is being used or protocol is being used. So to do that, we're going to go to our target machine. We're going to close this. We no longer need the result from the Regshot. We also need to close the Regshot application, and we still need to, because we are still going to perform another static analysis, we still need this one. So I'm going to keep it open. So the next tool we're going to use is the Procmon 64, which is another dynamic analysis or dynamic malware analysis tool. Now the way this one works is it just takes record of the entire processes that is happening in the background of the application, and then we can filter based on these different processes and connections. Now to use this tool, all we have to do is first of all do Ctrl E, which is going to automatically start up recording the different processes. Then we're going to go into our payload. I think we have it here, which is the malicious file. And then we're going to execute the malicious file. So can we double click on the hophelper.exe? I think I have to revisit that again. Double click on the hophelper.exe, and you can see that the payload has executed once again. So I'm going to click on OK, and I'm going to minimize what we have here. Now this is going to keep on capturing until we stop the capture. So to stop the capture, you can either click on this button right here, or you can still press the Ctrl E to stop. Now what we want to do is to filter these processes based on that particular malware, which is hophelper. So let's go to filter here, and then we're going to filter based on the process name. So we know that the name of the process is hophelper, and then we can add this to our filter list. Let's click on add, and then we can click on OK. So let's confirm that we have our filter. We're going to try to see if there's any request. There's none at the moment. So let's hope it's still capturing. Another thing we can do is to clear the filter and apply it again. So let's come here, remove the filter, and then let's use contain rather than just is, and then we can click on OK. Let's add it now. Still no result from hophelper. So let's try to see the next thing here. So it says we're filtering for TCP connections, right? What if we go back and add to our filter? So let's filter operations, and let it contain the word TCP. And then we're going to add this filter. So this is going to be the second filter, and we're going to click on OK. Still nothing. Let's remove the first filter, and we're going to apply. Still no result. That's strange. Okay, we have result from TCP, but we do not have result from hophelper yet. Let's try to play around with the process name again. Contains let's add that filter, and then let's click on OK. All right, so I think we have the right request now. We have about 4 of them, which happens to be connect, send, receive, and disconnect. So these are the kind of network connections that is taking place, and you can see that all the 4 actions are successful, and they are running TCP, and the protocol being used is HTTP. So this is the final puzzle for this challenge. So I'm just going to enter HTTP, and we're going to click on check. Can you find the web panel that hopheler.exe is communicating? So I would like you to perform these bonus tasks and give me a feedback. So we're just going to click on check, and lastly we're just going to click on check, and that will be end of day 6 advent of cyber 2025. So guys, that will be the end of this video. If you've learned 1 or 2 things on malware analysis today, kindly like, subscribe, and share. Your support helps me create content that you love. Thank you for your time, and I'll see you in the next video.